Going, going, gone. Astronomers find a group of stars that are leaving the Milky Way at what seems like impossibly high speed, and it turns out they have a deep, dark secret. Astronomer Warren Brown is taking me stargazing, but to understand what's really interesting about the stars he studies, I need to see them on a computer plot rather than through a telescope.
Okay, so here's one plot that's of interest, I think.
The stars we're looking at are in the distant outer reaches of our Milky Way galaxy, a sparse cosmic wilderness called the galactic halo. In images of the night sky, these remote stars look no different than the many, many nearer stars that are in the foreground. It's when the light of one of these halo stars is spread out into a spectrum that its true identity is revealed.
The plot you see here on the screen is a map of the sky, in this case in galactic coordinates, where you see galactic latitude and longitude. And so the colors of these dots represent the velocities of the stars, where in this case the blue stars, the wavelength's blue shifted, that is, they're moving towards us, and the red stars are ones that are moving away from us.
This relationship between color, direction, and speed is also known as the Doppler shift, and it's the standard tool in astronomy for figuring out which way things are moving and how fast. Since halo stars move differently from stars in the rest of the galaxy, this stellar speedometer offers a good way to spot them. But then, quite by chance, Brown ran into a star that was really unusual. Or perhaps we should say, it ran into him.
And when we measured its spectrum, it didn't look any different from the other stars that we were observing in terms of how its spectrum looked. But the velocity that the spectrum told us it had, that velocity was over 1.5 million miles per hour, which is an absurd velocity for a star in the Milky Way. And not only that, but given the faintness of the star, I mean, it's a very distant star. A star that distant, traveling that fast, is moving many times the velocity you need to escape the gravitational pull of the Milky Way forever. So this star is never coming back.
And just like that, Brown found himself looking at the fastest known star in the Milky Way galaxy, faster by such a large margin that he and his colleagues at the Harvard-Smithsonian Center for Astrophysics had to ask why. But the closer they looked, the stranger things seemed. For example, even though the stars of the galactic halo are uniformly quite old, this star was young, younger in fact than our own Sun. Clearly it came from well within the Milky Way, where younger stars are common. But why was it racing out of the galaxy like a steroid-powered flyball?
And so at first we didn't know what to make of that. It's one of those things where we observed it, and it was a surprise, and then we started investigating. So what could this be? And the explanation wasn't obvious to us. And that's where it got interesting for us. And so it turns out that half the stars in the sky are systems containing a pair of stars, or sometimes more. And so it's possible for pairs of stars to interact with one another like in a cluster of stars. We have many stars all close together. And now and then these stars can be tossed out when, out of the cluster. But those sort of, so-called runaway stars move at much lower velocities and are generally seen pretty near the Sun. So that sort of explanation didn't make any sense.
Another explanation they considered was that this star didn't come from the Milky Way at all. But that also made no sense, because such a star would have very different properties. It was at this point that Brown came across a remarkable idea.
And then I found this paper that was written by a theorist back in 1988, a Nature paper by Jack Hills. And he predicted that if you have a pair of stars that happens to get too close to a supermassive black hole, well, it's possible for the black hole to capture one star, and then the other star leaves with the entire energy of the pair, and so it is ejected with this incredible velocity. And suddenly, and that was my aha moment. I'm like, oh my goodness, this is a prediction of what we've observed.
Astronomers already have good reason to suspect that a giant black hole, millions of times more massive than our Sun, is lurking at the very center of the Milky Way. It's also a place that's densely packed with young stars, so it's easy to imagine that a close pair of stars could be caught up in the black hole's gravitational trap, with one star staying locked to the black hole forever, and the other getting kicked out of the system at incredibly high speed. According to Brown, if you could hitch a ride on such a star, it would make for an incredible journey.
So if you start from the moment that the star was flying around the supermassive black hole, at that moment it was probably traveling a few percent of the speed of light. So it was seeing things move by very quickly. And the galactic center is such a crowded region, you would see the sky just covered with stars, as bright as the moon perhaps, all over the place. But very quickly you would see that disappear. The number of stars would get fewer and fewer. And then after a few tens of millions of years, you're pretty much out of the galaxy completely. You're just traveling through sort of the really empty outer regions of the halo. And as the further the star goes, the blacker space gets, and to the point where the star will be lost in the blackness of space.